All right, so we're just going to finish up with while loops. In doing so, we're going to talk about a break statement. So what if you want to exit a loop? When you want to exit the loop, you would use something called a break statement. This is used to jump out of the loop abruptly, and break statements basically terminate loops. So let's look at a simple loop in processing. And this is static mode. As I said, loops work in static mode just fine. So if you have int I is 0 and you want to continue looping until I is less than 5, so here's our test condition. This is our statement, and this is updating. So if I run this, basically I'm going to get 0, 1, 2, 3, 4 printed. So this loop runs 5 times. At the end of the loop over here, it has the value 5, and I'm going to print out of the loop. Now, if I put a break statement down here, what this tells my loop is to execute this, and then break out of the loop. So the loop only runs once if I have a break statement in it. So basically, if I run this, then the output is going to be 0 out of the loop. If you felt particularly silly and you wanted to put a break statement on top over here, process. So this is process actually doesn't let you do this. So processing is interesting because if you want to do something particularly silly, it stops you. So here it says unreachable code. So it basically says, well, what's the point of having a loop if you're going to break it right from the start? So it doesn't actually let you do that. But if you put it at the bottom, it does work. So what happens when you put it at the bottom is I is 0, you print out I, you increase I, and then you break out of the loop. So what's being displayed to the screen, is, or to the console, is actually 0. The value of I in memory at this point is 1, and then you get out of the loop statement. If I, just to print a point, if I print out, so out of the loop, so let's say out of the loop, and I also say out of the loop value of I is, and I output I, then basically this is what we get. So 0 out of the loop, the value of I is 1. So go ahead and use these print statements regularly in debugging your programs. A useful use of the break statement is actually using them inside inside an if statement. So if you put it outside a condition, it just breaks out of the loop, and the loop only runs once. You obviously don't want that. But look at this loop in particular. So I have while true, so right away it's an infinite loop, but I'm saying print noob, which is what I've declared on top, and then I say if noob equals 10, break. And I'm increasing noob every step of the way. So it's kind of like taking a condition from up here and actually having your condition over here. One thing about while loops is that they are pretty flexible, so you could do these things with them. Later on we'll look at for loops, and you see they're a lot more rigid, where you can basically take the condition out from up there. I should mention that this is not, so the output is going to be 5, 6, 7, 8, 9, and 10. I should mention that this is not a good thing to do. It causes indeterminism, and it's just best to have your condition on top. But this is a feature of the language, and that's why I'm teaching. So let's take this code. Oops, go back. And let's try to run this in processing. So actually, let me write it over here. So if we have int I set to 0, and we said while I is less than 3, let's say, and in here we are going to have, let's say, print ln I, and of course our updating condition. So in other words, we have initialization, we have test, and we have the update operator over here. In doing so, we could have the identical code using a break statement. So we could have int I as 0. I could just say while true, and in here I would say print ln I, plus plus, and in here I would say if I greater and equal to 3. So let me write the break. So in this case, as soon as I is greater than 3, you're going to break out of the loop, or equal to 3, or you can actually say greater than 2. So that also works as well. So as soon as so both of these, the values are going to be, the output is going to be 0, 1, and 2. The output over here is going to be 0, 1, and 2 as well. So basically, as soon as I becomes 3, this will break, and as soon as I becomes 3, of course, this is going to break out of the loop. So these two codes are equivalents. So please make sure you understand this, and make sure you understand this code. As a practice to you, you should type this code in processing, and then try to make it so that you're able to put the condition up here to get the same value, which is 5, 6, 7, 8, 9, and 10. How would you do that? So if you don't have, like, if you didn't have the break here, let's go back. If you didn't have the break here, how would you modify this from true so that the output is still the same? So you would say while noob is less than and equal to 10. So what's really interesting is, if you look at these two cases, here we're saying keep doing this. So in here, the main difference is if you think about it, we still have number 1 here, number 2, which is the condition, is here. So this is the condition, that's number 2, and number 3 is actually up here. So the main difference between the normal while statement or the one that is using a break, here you're saying do, you're saying go through the while block as long as I is less than 3. So as long as I is less than 3, do keep repeating. Over here, you're basically saying stop if I is equal or greater than 3. And that's the very main difference here. All right, let's finish while loops by doing a very processing specific example here. So consider the following problem. We want to draw a set of 11 vertical legs, right? So we are going to, we're going to want them to be 20 pixels high, and we want them to have a distance of 10 pixels apart. So we want them basically to look like this. We want them to be all colored black, and we want them to be in a 200 by 200 grid. Left, we want them to start at x50 and y60, and go until x 150 and y is still 60. So at the same vertical level. So if you want to have this, one way is to simply just draw them manually. So you could have line at 50, 60, 50, 80, and then have it at so basically draw each line. So like each of these lines, you increase them by 10, because that's how you want them to print or to be drawn. So the other way is to actually use variables. And when you use variables, that's when you can actually use a repetition structure. So when you do use variables, you have a couple of variables here. We have x at 50 and we have spacing at 10. So using this, then we can use a formula where we can say line x and 60. So this is going to be 1 point, and then x and 80, and then increase x by 10, which is spacing, and so on and so forth. So you can kind of see this thing repeating 11 times, because you want 11 different lines. And we can actually pinpoint. So this is the step that is to be repeated. You have to think about your exit strategy. So you're basically saying you want to draw, you want to end when you reach 150. So this is your end condition. And I'm just going to fast forward a little bit. The slides are up for you to look at. But basically this is what you get. So you start x at 50 and you end at 150. So you're saying while x is less than or equal to 150, you want to draw this line where x is the x coordinate of the 2 points of one line, and then you would update, and this is your updating condition, and this will draw 11 lines for you. What you need to pay attention to is that the greater, the less than and equal sign here. So if you didn't have the equal sign here and you would just have less than n legs, you'll end up with 10 lines. But you want 11 lines, that's why you include the equal in there. If you didn't want to have the equal sign, you would basically have to set end legs to 160 so that you would still have your 11 lines. So go through this example, and hopefully while loop is clear for you. In the next lecture, I'm going to start working on the for loop. Thank you.